Hello. We are going to move on to our second section here today in Unit 3. Remember I mentioned in the last video we're skipping 3.1 day 1. So if you want to go ahead and move on to 3.2, that's on page 11. We'll get started. So I'm going to use all kinds of colors and things like that, so you're welcome to do the same or just mark things with whatever color you're using. Okay, so we're going to continue to look at things like corresponding angles, alternate interior, alternate exterior, consecutive interior. But this time we are going to work with parallel lines and not just two lines cut by a transversal. So what we've got are 4 theorems, actually 1 postulate and 3 theorems that we're going to define, and I'm going to kind of sketch out. Okay, one thing about my diagrams is I didn't get my parallel marks on yet. So if you would add, I'm just going to add, maybe I'll do it in red. I'm going to add that little symbol. If you want to make triangles, you can. I'm just going to make little arrowheads just to reinforce. Now they look parallel, but we don't want to go by the way they look. We need to see that symbol to give us proof. So let's fix all 4 as we begin. Okay, we are going to first deal with corresponding angles. So I left you a spot right here to write the name of the rule. So this first one is going to be called the corresponding angles postulate. Corresponding angles postulate. Okay. The corresponding angles postulate. And so it says, if 2 parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. All right? So if I have parallel lines, then I know my corresponding angles are congruent. So I want to go through here. I think I'm going to switch colors, so I hope it shows up on the screen of my 4 sets of corresponding angles. So I'll just stick with my first color of blue. I'm just going to use dots, I think. So I will put 2 blue dots in 1 pair of corresponding angles. We'll switch to red. Another pair in red. I'll just put the 2 dots. If you want to number your picture, you can. I'm just trying to show you the different colors or the different sets. Let's go with pink. I think that will show up differently than the red. So I'm going to put a dot here. It's pretty close, and a dot here. And then let me go to a green one and see how this one shows up. Let's do green and green. Okay, so what I'm going to say here are 4 pairs. That's the main thing you want to take away. All right, so I have 4 pairs. So separately there are 2 sets of 2, but the 4 pairs are, one part is congruent to the other. Okay, so it's called the corresponding angles postulate because it talks about the corresponding angles being congruent. All right, the next one is alternate interior angles theorem. Alternate interior angles, and this is a theorem. Theorem. Now, I don't have a very good reason why the first is a postulate and the rest are actually theorems. Oftentimes postulates are a little bit more basic, and then the theorems build off of the postulates, but the rest are theorems. So it says, and notice these are all conditionals. Your theorems and postulates are all in the form of an if-then statement. If 2 parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. Okay, so we only have 2 sets, so I'll just have 2 colors. Alternate interior, so I've got the 2 blue dots right here, and then I'll switch to pink. 1 right here and 1 right here. Okay, so the 2 sets are congruent. And when you've got parallel lines, you should visually be able to see that they're congruent. So look at the opening around this blue dot. It's about the same as the opening around this one. Okay, you don't want to make that be your only proof that things are equal, but it helps reinforce the idea that they're congruent. Okay, our next one is the alternate exterior angles theorem. Alternate exterior angles theorem. Alternate exterior angles theorem. Excuse me. If two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. So we kind of have a congruent theme going on. Alternate exterior. Let's see, one set would be these two blue dots, and then the other set would be the two in pink. And again, you can see, if you look at the size of the angle opening, it should be about the same on both. Okay, our final one is our last set of angles, our consecutive interior angles theorem. Consecutive interior angles theorem. Okay, so this says if two parallel lines are cut by a transversal, then the pairs of consecutive interior angles are supplementary, all right? So notice they're not congruent. So let's mark, I'm going to mark in blue the two sets of supplementary angles. Okay, I'm going to put here, I'm going to say equals 180. Now they don't individually equal 180, they add to 180. Notice how one is acute and the other is obtuse. They're clearly not the same size, but they will add up to 180. Same thing over here. I'm just going to identify them in pink, equal 180. All right. Now, notice too, my one blue and my one pink are alternate interior. Those will be the same. So let's say, for example, this acute blue dot is 80. Well, this pink dot down here is 80. If these are supplementary, that one's 100, which matches the other 100. Okay, so of our four rules here, congruent until we get to consecutive interior. And if you really pause and look at the diagram, if you have parallel lines, one will be acute and the other will be obtuse, unless they're both 90. Okay, so if they're both 90 and your transversal's perpendicular, well then obviously they'll be congruent and supplementary. Okay, these names you need to know. They show up in proofs, okay? And they're not hard to learn because they match the type of angle you're looking at. So if you're dealing with corresponding angles and you have parallel lines, well, the reason they're equal is the corresponding angles postulate. All right, let's go on to a couple examples here. Find the value of x, or find x if line L is parallel to line M. All right, so here are my parallel lines. And in fact, I might go ahead and do that just to reinforce that. So if I have parallel lines, I have these relationships occurring. So let's look for one of those. Okay, find the value of x. So this x right here in this angle and this x over here, I don't really know the relationship with each other. But I do know, let me kind of mark here. Let me use a pencil because I might erase it. So this angle right here, these two together make this big angle. And then this angle right here, these are consecutive interior. Okay, so I'm going to erase my arcs because I don't want you to think they're equal. Because if these two added together and 70 are consecutive interior and the lines are parallel, then I know the angles are supplementary. So I need to actually add these two together plus 70, and then that equals 180. Okay, so step one, identify what they are, and then step two, the relationship is supplementary. So I can take x minus 20 plus x plus 70. That has to all add up to 180 because the lines are parallel. Okay, x plus x is 2x. I have basically 70 minus 20 is 50. Take away 50. So that is 130, I believe, right? 5, 6, 7, 8, yep. Divide by 2, 65, I think. Let's just double check. 130 divided by 2. Yeah, 65. All right. Find the value of x. So we are done. I don't need to plug it back in and determine a degree measure. Now, I could have done it a little bit different. If I know that this angle is 70, then I could have said, well, if these are supplementary, so if I did 110 minus 70, then, oh, not 110, 180 minus 70, excuse me, is 110. I know that these two here have to add up to 110. So then I could have done x plus x minus 20 equals 110. Okay, so there's going to be a number of ways to do your work. So don't hesitate to ask, well, can I do it this way? Because you might be just fine with what you're doing. Okay, let's go on to the next page. Okay, I would like you to pause and come back and try number 2 on your own. I'm giving you an angle measure. I want you to find these angle measures and then describe what postulate or theorem you use. And so you're quoting one of these 4 here that you have used to get to your answer, or prior theorems or postulates. So go ahead and pause here and then come back and we'll take a look at it together. Okay, letter A, measure of angle 6. So I'm going with angle 5. So 6 and 5 don't fall under one of these categories, okay, because they're together in a group of 4 angles. But I have another reason I know that 6 is also 65 degrees. It's because these are verticals, and so the vertical angles theorem says, hey, those are equivalent to each other or congruent. So 65 degrees, and so instead of quoting one of the new theorems, I'm going to call that the vertical angles congruence theorem. Vertical, if you want to use the abbreviation for angles, you can. Vertical angles, we can say vertical angles theorem or congruence theorem. I'm just going to say theorem because I'm about to run out of space. But when you attach the word theorem onto it, that talks about the reason why they're equal. If I were to have just said vertical angles and stopped, then all I'm doing is saying, oh yeah, I can tell 5 and 6 are on opposite sides of a group of intersecting lines. That's all I'm saying. I'm not, the theorem attaches the value that they're both 65. Okay, number 7. So number 7, I'm going to go back off of the given. Number 7 and number 5 are a linear pair. So I know that they are supplementary. So that would be 115. And so the reasoning that they are supplementary is not just because they're called a linear pair, but it's the postulate that says that they are supplementary. So linear pair postulate. Now, if you confuse theorem and postulate, if you would have said linear pair theorem, that would be fine. I'm not going to get hung up on that particular word, but attaching that word is what gives it the value. Okay, 8. So if I go back to my 65, 8 and 5 are corresponding angles, and since the lines are parallel, the corresponding angles postulate says that they're equal. So 8 is 65 degrees as well, and this is the corresponding. And I'm going to do a little bit of abbreviating now. So you can write the whole word out if you want to, or you can abbreviate. I like to use this angle symbol, postulate. Okay, corresponding angles, postulate. Okay, number 9. So from 5, 9 doesn't have a direct relationship, but I could relate it back to 7. Okay, so we said 7 was 115, so that means 9 is 115. So I'm going to say that 9 and 7 are congruent by the alternate exterior angles theorem. So alternate exterior angles theorem. And I'm going to put in parentheses here with angle 7. Okay, because if I were to say alternate exterior angles theorem with 5, then that is not a correct relationship because 5 is 65. Okay, so I want to clarify which angle here. Okay, let me see where we're at here. I think I want to, yeah, I'm going to stop the video here, and then we're going to go on to a few more complicated solving ones. Okay, so let me pause this video or stop this video, so feel free to move on to the next one.